Players in a basketball team take 33 throws each during a practice session. They have a probability of 88% of being successful in any free throw attempt. Michael takes 30 free throw attempts during a practice session. Find the probability that Michael successfully shoots 25 free throws. So the first thing to note here is that we have a binomial distribution. There are 30 trials. The probability of success of any trial is 0.88. And we want to calculate the probability of x equals 25, and this is just calculator work. So we're going to head into statistics. But this time we want to go to distribution and then binomial, which is F5. And this is a single value, which is a BPD. And then what we want to do, the data needs to be variable, so that's good. The x is the number of trials, so we're going to put in 30. Oh, no, we're after 25. The x is not the number of trials. The x is the number of successes, 25. Number of trials is the one that's called num_trial. And so that is going to be our 30. Probability of success is 0.88. And then we get 0.1451. Let's just give it 3 significant figures. Find the probability that Michael misses at least one free throw. Well, that just means the probability that x is less than 30. To get all of them, he would get 30. So anything less than 30 is missing at least one. That is equal to the probability of x being between 0 and 29. And again, that is calculator work. So if we just go and grab the calc, and we'll exit from that and exit again. So again, distribution, binomial. This time it's a binomial CD when we want a range of values. And so the lower is going to be 0. The upper is going to be 29. We have 30 trials, probability of success 0.88. That's already been brought in from the previous screen that we were on. And so we'll just execute and we get 0.9784. Let's just call it 0.978. Michael's coach found that all players in their competition, consisting of 222 players, also took 33 throw attempts during their practice sessions. The number of successful free throws made by players in the competition can be modeled by a normal distribution with mean mu and standard deviation 1.25. Given that 20% of the players made more than 24 successful free throws, find the value of mu. Okay, so let's just have a sketch of the situation. So here is our normal, and this is the mean, and this is 24. And so what we're told is the probability of being up here is 20%, or 0.2 as a decimal. This distribution is a normal with a mean of mu and a variance of 1.25 squared, since the standard deviation is 1.25. Now, if this is 0.2, what we really want is the z-score for this value. In other words, we want to look at it as a standard normal. Okay, so we want distribution, we want normal, and since we're finding a value, we want inverse normal. The others are for finding probabilities. So tail, we want set to right. That's perfect because here it is. You can always choose left or center. The area is 0.2, perfect. Now we're wanting a standard normal, so standard deviation needs to be 1, and mean is 0, so that's all good already. So we get 0.84162. So our z-score is 0.84162. Now we know that a z-score is equal to a score that we know take away the mean for the distribution divided by the standard deviation. So what we must have here is 0.84162 is equal to the 24 take away the mean over 1.25. That's just a case of solving on the calculator or just rearranging here. It's not straight, it's pretty straightforward. So 24 take away 0.84162 times 1.25, and calculating that gives us mu is 22.9. Find the number of players that are expected to make between 15 and 20 successful free throws. So we now have that we have a normal 22.9, 1.25 squared. And we just want to find that x is between 15 and 20. And so that's just calculator work again. I won't bother going through it. 0.0102. And then that's the probability, but we know there are 220 players. So 0.0102 times 220. And that gives us 2 with a bit of rounding. Has to be a whole number of players. Find the probability that of the top 20% of players in the team, they will make at least 25 successful free throws in the game. Well, the situation we have been working with is the situation that we can see above. I'll just reproduce part of the diagram here, in that we're looking at those that make 24 and above. So what we're looking at is x being more than or equal to 25, given that they make greater than or equal to 24, because we're only dealing with those players. And so that would be the probability of x being greater than or equal to 25 and x is greater than or equal to 24, divided by the probability of x being greater than or equal to 24. And the top of that, because we're looking at a situation like this, where we have 24 here and 25 here, and for an and we're looking for both to apply, the top of that just becomes x is greater than or equal to 25. We have a probability of x is greater than or equal to 24. And this is just calculator work. So if we do the x is greater than or equal to 25 with the values we have, we get 0.04647 and so on. We know the bottom is 0.2. We were given that earlier on in the question. And so that comes to 0.232 if we round to 3 sig figs.